It's just me now. That was not a great start. Not sure if I can hear, cannot hear Daisy, can't hear Daisy. We're live now, but we can't have Daisy. Can't have nice things. Oh. Chaos. Can only hear James. I've got some engagement though, because like 100 people have told me that they can hear this. Goodness me, can't hear Daisy. Also, is there also the windows overlapping from a different bug about trying to capture Daisy. Right, cool. More preparation needed. We will get Daisy live at some point in the future. Very, very quiet. Can I share the computer audio? I am sharing computer audio. Can I get OBS to do it? Yes, I can. That is what's going on, which hasn't worked. It's real pain. People say bye Daisy in chat. If I share, I'm sharing computer audio. We did it before to listen to Desmos, which was the plan. That was the plan. It was going to be like Desmos. Welcome to the computer science live stream. Raphael's right. This is the computer science live stream where none of my tech wants to work at all. Is there a difference between computer science and technology? I think there probably is. Look, separate bug, by the way. While we're complaining about bugs, I have to use Firefox now for this. This isn't full screen. Right. Live, eh? Who's Daisy? Daisy's a computer science student who is supposed to be here, who I sadly can't capture due to tech failings. It's a disaster, isn't it? Right, good. Someone's using my username. Somebody in chat has chosen the username JSpondRoad, which you can do if you want to join live chat and take part in this incredibly well coordinated Matt live stream. Then you can do that over in Slido. I think there's a link on screen. Good, right. Okay, I am now going to do a Recursion live stream, and we're going to get that to work. Bad at social media, making websites, and Photoshop. I don't think those things are computer science. Yeah, Daisy did that. Can't do that call now. Everything goes wrong. Right, okay. So, what are we doing? We're doing Recursion. Yeah, I think the worst one was probably the one where I completely failed to go live at all. I think this is coming second at the moment. There were a couple like that, weren't they? Weren't there? Break the audio. Okay. So, Recursion, like primes and proofs last week, there's no content on the MAT syllabus that's explicitly about that, but you are expected to be able to do some sequences and series stuff in tricky situations. They might have these things with more than one input to the function, which I think we talked about a little bit before when we looked at some questions with functions in, and they had more than one input. There's a different notation that I wanted to put on this worksheet, where the functions might have two inputs like this, which makes a bit more sense. Or it might be like one subscript down here, which we saw for a previous question. What was it? It was that thing that was f subscript k of x. I think we saw that, where it was a function that had x's in, but it also had k's in. So that was a thing that was happening before. Yeah, so people who've just joined us, we were supposed to have a guest on today, but unfortunately the tech didn't line up very well, and we couldn't hear the guest. So we're going to organise something else. I haven't quite worked out what yet. Let's do a poll. How's your day going today? My day is at 1 star. Solid 1 star. Let's try and enumerate the things that are going wrong in my live stream. No, let's not. At some point I'm going to go past some sort of 100 of these or something. Anyway. Nicholas asks, is this live stream any good for non-computer science applicants? And to be frank with you, I'm not sure it's great for anyone right now. I'd hope that math students can get something out of this as well by seeing functions presented in a slightly different way and think about these sort of counting arguments. Plus, there's some overlap sometimes on question 5, which everyone does, which might have this. Something about unlisted streams. Yeah, good, cool. I need to check all of my settings. This is failure to practice. We've all learned something. Oh, chat's voting quite high. That's nice. So chat's voting for a day that is about 4 stars, which I quite like. That's going very well. Question 5, loads of greater than signs. The volume quiet. Oh, that could be me. This is the sort of chat message. Does anyone else think the volume is quiet? It's just the sort of chat message that I didn't want to see. Hi, if you've joined this, if this is your first live stream, then it's not always like this. It is quite often a bit like this, but not always. Not always. Right, that bar chart's slightly taller. There we go. You are supposed to use pens for the mats, by the way. There's a question that's coming in here. Pens for the mat, please, which is what it says on the front. If you write in pencil, then there's a danger that it won't be picked up by the machine that scans the pages, which is what we're going to do with the mat. Good. What's the difference between F subscript K? So kind of nothing. Kind of no difference between those two concepts, really. They're both functions that take two inputs. You would never mix and match them. If somebody comes up to you and says, "Oh, I've got this great idea for a function X, Y," you'd never interchange it and choose to write it as F subscript Y or F subscript X. These are kind of three different ways to write the same idea. But it's a good idea to be consistent. Once you've picked how you're going to write your function, it's a good idea to stick with it. People tend to use this sort of thing with the subscripts in when they're thinking about. Normally when they're thinking about something that's enumerated down here by whole numbers in the subscript. We've previously seen a maths question where that's not the case. It was a set of functions that were enumerated down here by the real numbers, which is quite a lot of functions. That was the thing where we had F subscript K, and the K was a parameter in the expression. I don't need to write that anymore. So being consistent between those is a good idea. But otherwise, doesn't make much difference. Can you use blue ink? I think it says use a black pen on the front, but I reckon blue ink scans pretty similar to black ink. I once was told in school that blue ink and black ink are the same thing. Black ink is just very dark blue ink. If you get one of those chromatography things, has anyone done this? Do they still do this at school? Where you put like a blob of pen ink on a bit of paper and then you dip it in water at the end or something? Some sort of solvent maybe? And the water goes up the paper and it smears out the ink into its components. I'm not really sure what it's based, why the components go different distances. I can't remember how that works. But anyway, that's black ink and blue ink are kind of the same thing, but different mixes. Did anything exciting happen to me today? Anything exciting I did? No, I thought I'd lost something, but I found it in my office. My office is a mess. So my most exciting thing this morning was coming into the office and finding a thing that I thought I'd lost. Chromatography, yeah, GCSE chemistry. Oh, okay, brilliant. So now chemistry live stream. I've lost my computer science guest, but chemistry live stream. That might be fun. I'll talk to chemists. That's like a good idea. We don't have Prisma this week, so I'm also moderating chat. The idea being that we have a guest who's talking about the maths questions, and I'll moderate chat. Oh yeah, so top question. Before we get into the recursion, let's get some other things out of our system. We've done the vote. The vote went quite well there for how people's days are going. As always, looking out for people whose days aren't going brilliantly. It's probably not going this badly. Or maybe it is, I don't know. But gosh, I've just wasted 15 minutes. There's a request for question 1 on the warm-up. I think we've got time to do all the warm-up questions, to be honest, because there are only 4 of them this time in the warm-up, which is maybe a more sensible number for warm-up questions. I got a request for a volunteer from chat to moderate. What could go wrong? Anything else we want to get out of our systems? What was the thing I found that I thought I'd lost? Oh, I'd lost my coat. Because I have a habit of taking a coat to a thing and then just leaving it there. But it turned out, nope, I'd actually not taken it. So that was brilliant, just in the office. Good, right, okay. I don't think it counts if chat mentions them. If chat mentions them straight away. So when they become like relevant, right? Or maybe it is when chat mentions them. When's the last live stream? I mean, some would say last week, because this is not a live stream, right? I mean, we're live, we're streaming. Oh gosh, there's about 100 people here. Right, let's try and get on topic. What key topics do we need? We're going to go back and revise sequences. I quite like the way these ones bookend the kind of content of the MAT Livestream show. At the front, we did sequences and series way back at the start, and now we've got recursion, which is more sequences and series. So that's kind of core skill. There's sort of some methods of the way that you explain things and the way you write things down that we're going to try and dig into later, that I think is core and comes into that kind of clarity of thoughts about how you get things. But I think what we've really got to do is try and go through some of these examples. Okay. Here's a sequence. It's been defined for us, and we're going to try and work out what's going on with the terms. Good. Oh yeah, trapezium rule. Someone asked for the trapezium rule. Let's do the trapezium rule first. Trapezium rule used to be early on in A-level in your A-level maths experience. You used to have the trapezium rule in there. So we used to write math questions that used the trapezium rule. It was sort of fair game because people knew about the trapezium rule. These days, the A-level syllabus has been changed, and you don't know about the trapezium rule necessarily. I mean, some of you maybe do, but you don't necessarily know about the trapezium rule, which means I can't ask any questions about the trapezium rule. The trapezium rule is a way to estimate an integral. If you want to integrate this function, you know that integration means find this area underneath, and a good trick is to draw some dots on the function at equal intervals, and then join the dots at the top to make a whole load of trapezia. These shapes here are trapezia. Trapezia, two parallel sides, but the other sides aren't parallel because they look like this. And then if you add up the areas of those trapezia, then you get something that's a bit like the integral between A and B, or whatever. That's the trapezium rule. People learn a formula for adding up all the areas of those trapezia. So yeah, it used to be sort of okay, but there's a few past math questions. If you're looking at past papers, in the table of past papers on the MAT website, there's a notes column where we've gone through and we've added a note. We've had like a comment in a separate column, in a separate page, with a comment to say that a past question uses the trapezium rule. But it's usually obvious because it will mention some trapeziums or it'll mention approximations to an integral or something. Okay. This is a really good... this is maybe a system that is this is maybe relevant in a way that if you're interested in computer science, then this is a way that a computer could have a go at doing an integral. So your computer is unlikely to be able to just write down a function that is the integral of a given function, but it could have a go at doing a definite integral by evaluating it and using the trapezium rule. It's not amazing as a way to integrate the function, but it's okay. Good. Trapezoids. I think trapezoids are the 3D sort, but that's not something that I consider myself to be an expert on. You can safely ignore past questions on trapezium rule in past papers. I have not included any of them in this MAT livestream experience because there's not going to be any questions about the trapezium rule where you're assumed to know about the trapezium rule in MAT 2022. Is it fake integration, or is it actually what integration is? Ooh, what? So that's a tricky one. Good. Yeah, something about the Vieta's formula. You still got the marks? Yeah, as long as you follow the instructions. If you follow the instructions in the question, then any method should get you the marks, even if it's more advanced or whatever than the stuff on the syllabus. Sometimes the questions, watch out for this, sometimes the questions tell you by using the previous part, or they say hence. Hence means using the previous thing. So hence, find out this from the previous thing. Then you've got to follow the instructions, and you've got to do it like that. But if it's just sort of freestyle, then you can bring in anything you want. Cool. I am dodging this because I didn't say no integration, right? I didn't say no integration, I said no trapezium rule. Good. I am dodging this one because I've realised that this question looks like a lot of work. It's a sequenceless question. Let's have a go at it. Let's have a go. It's one of those ones that starts at A0, which I remember that about 50% of you like. The other 50%, of course, believing that sequences should start at A1. So let's quickly work out A1 just to help everyone out. The sum of all previous terms. I guess that's just 3. And then A2 is the sum of all previous terms is 6. And then A3 is the sum of all previous terms is 12, and then A4 is the sum of all previous terms is, it's 24. So I guess we're being asked to spot a pattern, or to work out maybe what AN is equal to. And maybe there's a pattern here. Integration is like the trapezium rule, but with no gaps between the dots. I guess that's sort of how limits work. Why is everyone asking about soft drinks? I don't get it. I like all the cola based ones. Is it going to be like a 50-50 thing, where if I express a preference for one of the sorts of cola, then half the audience immediately switches off? Oh, Harriet's ready to restart the 0-1 argument, I think. Is it going to double each time? It definitely feels like it's going to double each time, because, well, it's been doubling so far except for the first bit, and, well, it feels like it's doubling because this 24 is precisely this 12 plus this 12 for like all the previous ones. The AN is equal to AN minus 1 plus all the others, but all the others was equal to AN minus 1. So this is just 2 times AN minus 1. This is not how algebra actually works, but it's much faster for me to write all the others than it is for me to actually give it a name in algebra or something. GCSE question in chat, which is a very valid question, I suppose. For now, don't worry too much about GCSEs if you're applying for maths or computer science in this round. We're working it out. Still not totally clear what data I'm getting from various data sources. Yeah, we were never putting that much weight onto GCSEs, if that makes sense. Because your GCSEs are not all in maths, and we have this lovely maths test, which is all about maths. I didn't count water as a soft drink. I understand it's getting loads of votes, and yeah, it should be getting votes. I understood soft drink to not include water. Obviously, everyone should stay hydrated throughout the live stream. Lots of people who score, okay. What's a good score to aim for CS applicants? They produce their own statistics on the CS website. There is a document, a bit like the maths document on the maths page, with averages of previous rounds and things like that. I would say about the same, I think, broadly speaking. Higher the MAT mark, the better. Okay, what was my final answer? I've got this kind of recursion statement now. Recursion is where something relates to previous values of the function. Not a great definition. Wish I had a computer scientist here who could say something more pithy. So here I've got AN is equal to 2 times AN minus 1, that each term in the sequence is double the one before. That's quite familiar a concept, I think, because that's how geometric series work. Spoiler, this is a geometric series. But which one? And what we're asked to do now is to solve for AN. You can't always do this when you're given a recursion relation like this one in the box. But in this case we can, because we know that when you multiply by 2, that's called the powers of 2. Oh, okay, allow for the fact that the first one is 3, but I think that means that this is 3 times 2 to the power of, and now I've got to really concentrate. Is it 2 to the power of n, or is it 2 to the power of n minus 1? It depends if we started at 0 or 1. I'm going to check some numbers in my head. If I plug in, I'm not done yet. If I plug in 2, then that would be 3 times 4. I don't want that, I want 3 times 2 for 6. Good, right, cool, I'm done now. 3 times 2 to the n minus 1. Zeros and ones. I guess the 50% of people who like starting sequences at ones have a better time with this question, maybe? Oh no, even worse, up by 2. Because you have to write down n minus, anyway, good. If you start your sequences counting from 2, then this question's great. Is that true? No, that's not true at all. Is it? Have I got it wrong? Can it be 3 to the 2? Yeah, that's what I wanted. I'm hoping that conversation, that one came in before. Back substitution. Yeah, so a kind of slightly strange way to write this is to say something like this. So AN's the sum of all previous terms. And then to use the fact that, gosh, this is a bit mad, isn't it? To use the fact that this AN here, to maybe think about expanding that AN minus 1 in terms of AN minus 2 plus this one itself involves everything over there. Which looks like a complete mess, of course. But look at the numbers in the subscripts. on the left we're looking for an, and on the right we've got something that involves lots of different subscripts. n-1 is the biggest number in those subscripts, but then after expanding it out like this, the biggest subscript is now n-2. So although the expression has got much wider, the kind of order of the problem almost, or the depth has reduced slightly. That now we've got a statement that relates it to previous terms, not including an-1, slightly more previous. And in theory, I don't think this is a good way to do this particular question, but in theory we could keep expanding. We could say, aha, I know a rule for this one, it expands, and this one over here expands in terms of previous terms, so we could keep hitting it. And as we do that, we'll eventually get down to some sort of relationship between an on the left and equals, so I think this turns out to be 2 to the n-1 times a0, or something like that. There's sort of, you keep expanding everything and you end up with lots of copies of a0 after hitting absolutely everything you can see, and keep hitting it until it boils down to just the a0s. It's not a great way to do the question because the expressions get very, very wide very, very quickly, but in some sense that's how recursion problems really work, that you're trying to relate it to previous values, whatever previous means. That's something we're really good at. And then if you can relate it to previous terms, you can relate it to previous terms, keep going down. There's a really famous sort of example of recursion problems that all the computer scientists in chat will have heard of, where you try and explain to a computer how to work out factorial numbers. Now you probably already know the definition that n factorial means this thing, n times n-1 times n-2 times ... times 2 times 1. And I think maybe that's a little bit hard to explain to a computer, that like the length of this sum is sort of unknown when you set off to work out 10 factorial. I mean, it's 10 terms, but then you've got to work out, you've got to list all the terms maybe and multiply them together. So a cool definition is to define n factorial as n times n-1 factorial, and define, I suppose, 0 factorial to be 1. And then if you code that up in your computer, it can work as a definition, because then when you ask for 10 factorial, it will say, aha, I need to do 10 times 9 factorial, and then it will think about that 9 factorial, and it will loop back around and think, 9 factorial, I need to think about 9 factorial as 9 times 8 factorial. Well, what's 8 factorial? I'll go for it over here. So you can do some sort of if-then. If you're looking at 0, then stop and do this. If not, then do this sort of returning go-to statement. Good, okay. Another sound issue someone's noticed is that there's some building work going on nearby, which sounds like hoovering in the background. I'm sorry if that's picked it up. Good. Would it be easy to combine all the terms? Come on, chat. There we go. I'm Perelman says, wouldn't it be easy to combine all the terms? We just get 2. Yeah, I think it would. I wanted to make this point about expanding everything. So this is kind of a stupid way to do this particular problem of just expanding everything. But yeah, it's probably easier to, in this case, concertina all of this together and say all of this stuff is an-1 as well. So cool, now we've got a nice simple statement. Good, okay. Okay. When do people find out if they're going to get an interview or not is a question in chat. At roughly the end of November, very start of December, we send out all those emails about a week before we're doing actual interviews. Either way, to make people know. Try to give people some notice. I think the dates for interviews are on the website somewhere. I think it's the second week of December we're doing maths interviews. Okay. I'm going to skip question 2. Well, I'm going to let you do the adding up. No, let's go for it. Maybe it's good for us. Yeah, maybe this is good for us. So we can work forwards or backwards for this one, for the Fibonacci numbers. I'm going to do both. Yes, could you also write it as, sorry, before I move on, sorry, I would always rushing to move on to new things. You could also write this as 3/2 times 2 to the n, if you want to. Maybe that looks nicer. Actually, maybe it does. Yeah, okay, I like that. Yes, you do get an email either way. Okay, I'm going to try closing this. How do I do that? I just press quit. There we go, good. Oh, everything going wrong. Do I prefer teaching or research? I no longer do any research, so I'm going to pick teaching out of those two. Was there a comment about erasable pens? So I saw a comment about erasable pens. Here it is. I saw a comment about erasable pens earlier, and I assumed it was a joke. Skip warm-up question number 2. It is a bit of a classic. It is a bit of a classic. I kind of want to do it in the stupid way as well, to show you that, like, so you could work upwards to work out some Fibonacci numbers. But an option that's available to you, oh gosh, this is James adding and writing down numbers at the same time again. An option that's available to you is that you can work out that f10 is equal to f9 plus f8, and then expand that again to write down that it's 2 times f8 plus f7. So I've expanded the f9 to say that f9 is f8 plus f7. So I've got now 2 copies of f8 and an f7, and then I'm going to expand the f8 to say that that's 3 times f7 plus 2 times f6, I think. So this is kind of nice. And maybe this is a fun exercise for you to try if you want to try a recursion problem where you work downwards by expanding from the top. These are both options available to you. I can't say which one's best. I can say which one I find easiest, which is the first one of just writing out lots of numbers. We're going to see some problems later on where maybe expanding the second one is better. It's probably good for you to just be aware that both of these things exist, whether or not you plan to actually do them. Hopefully you've noticed that we're getting some coefficients out here as I expand these things, sort of following through now. What if I never follow through on any of these questions? What if I get here? 3f5. Hopefully you've noticed these coefficients are a familiar sequence of numbers. They are in fact the Fibonacci numbers in this expression for Fibonacci numbers. And when we're done, we're going to get down to something involving f1 and f0, at which point it will tell us to just add the numbers together. We know f1 and f0, and that's when we get to add. Thanks, Guy, for the summary. I think that is how it's going so far in there. Do you need a camera for interviews? That was a good question. I think look, I'm going to say if you've got access to a camera, then we would like you to turn the camera on so that we know it's you doing the interview. I can't remember how the policy is worded for this one, sorry. I think we really sort of strongly prefer to have a camera if at all possible, so that we know who we're interviewing. And can you bring a timer, not a joke, for the interview, or for Matt? For Matt, I'm not sure. I think that in Matt that might count as some sort of electronic device that you're not allowed to bring along. There should be probably an invigilator keeping track. For interviews, I can't see what you would do with the timer. I don't understand why you would want a timer. Right, good. It's this complete failure to finish anything as well. I've just gotta keep going. How many F5s have I got? I've got 8 F5s, 5 F4s. It's going to be amazing if I get down to the right answer. I expect everyone to be extremely impressed. F3, and then this one I'm going to keep expanding. So I'm going to get 21 F3s plus 13 F2s, and then I'm going to expand that and get 34 F2s plus 21 F1s. Everyone with an F1 and username in chat, get excited because this line involves an F1 plus, what is this going to be here then? 34 times F0, but we know F1 and we know F0, those are both 1, so this is 89. Hooray! May have got the right answer. Oh, people are great, aren't they? Well, can you do an egg timer, non-electronic? I don't see why you can't take it. I don't see why you can't take an egg timer into the mat. I mean, it's not on the list of permitted equipment, so probably you can't get away with it. But I can't see what you're going to do with it. Can you wear a watch? You can wear a watch, but probably not a smartwatch. Probably not a smartwatch that has a calculator in it, for example. Sometimes this jokey stuff I have to remember that also not everyone finds the jokey stuff funny, especially if you're scared about maths. It's going to be okay. When it's actually happening, it's maths questions. The way you get more familiar and happy about this experience is to just do some maths questions, and it doesn't matter if you solve them all. And I mean that both for practice and for the actual mat. You don't need to get 100. Good, cool, brilliant. Other clock jokes? Am I just calculating the Fibonacci sequence backwards? I suppose I sort of am. It's interesting, isn't it? You might like to think about how other sequences work though, because if we were thinking about the completely original invention of the Monroe numbers, my IP, don't steal, which is defined by f0 equals 2 and f1 equals 1, and then the same sort of, I'll just keep this bit. There we go. Pretty sure somebody else has got their name on these already. Then the forwards way of working out the Monroe numbers involves completely different sums, because you've got to work out the next one's 3, and then it's 4, and then 7. I should know the Monroe numbers, which I've just invented. 3 and 4 and 7. But if you work backwards, you actually do the same thing that we've done above. So working backwards, you get down to here, and then you would say at the end, you would just say, this calculation of the last step here, where I plug in the numbers, is different. So somehow this backwards working is reusable for a different equation with different starting numbers, which is maybe a bit good. To say that one again, the numbers are the Fibonacci numbers, but that's sort of a coincidence that these numbers turned out to be the same numbers in the actual sequence, because if the first two numbers in the Fibonacci sequence were different, then that wouldn't affect our backwards working, but it would affect the numbers in the Fibonacci sequence. Good. Are these the Lucas numbers? Have I accidentally done exactly the Lucas numbers? That was my worry when I thought, I've done exactly the Lucas numbers. There we go, okay. You never get to put your name on anything. These are called the Lucas numbers, and you can look them up. Nothing is original under the sun. Right, good. Okay. As soon as I wrote down the 2, I thought, oh gosh, I've got to avoid the Lucas numbers. Sorry, Lucas, if you're watching. Good, right, cool. Okay, for more on the Lucas numbers, check Wikipedia. But also, everything you need is on the board. Okay. 95% of people who shortlist have got A-level further maths. I don't have it due to not being able to run it. We make an exception for if your school is not able to run it. We don't want you to be disadvantaged. So it's true that lots of people do have further maths. Most people who are doing, I guess most people who are applying are lucky enough to be at schools or colleges that have further maths. But it's not your fault. Your school or college doesn't do further maths. Good, okay. Save the name Monroe numbers when you prove the twin prime projector. Okay, do we rename the twin primes into the Monroe primes or something? Yeah, cool, okay, good. Brill. And am I proving that there are loads of Monroe primes, or proving that there are no Monroe primes? I'd quite like to have a set of numbers that there are none of. I think that might be fun. Like how there are no solutions to that equation for Fermat's last theorem for large values of n. I think it'd be quite fun to refer to those as the Fermat numbers. Oh no, there aren't any. Oh, the Fermat numbers are a different thing. This is a car crash of trying to name things today. Good. Am I interviewing this year? Yes, I think I am. I've just been offered some interviewing, which I'm excited. This is a great tip. I like this. This is getting flagged. There we go. In amongst all of the other stuff. If you don't finish the questions on the MAT paper due to time, so just before you run out of time, epsilon before you run out of time, just a little bit, can you quickly write down a method you think is right? Yes, you can. Literally, you can write down, you can literally write down a method. But also, I think what you mean is, will I get any marks for it? And the answer is maybe yes, because we might be able to give you a method mark for having a sensible method. You should also realise that we don't know that it was the last thing you wrote down in a hurry. So if you write down a method, we take that seriously. We don't think, they've just scribbled that down in the last minute. We don't judge you on your handwriting. If we can read it, then we assume that you mean it seriously as an attempt at the question, and then you can get method marks. Just like if the person sitting next to you, right, has spent an hour thinking about it and then written down the same thing, we can't tell, right? So for all we know, it's like not a time-saving thing. It's just that's what you did. So we have to give you the marks. Brilliant. So essentially, this question is: if I answer a question at the end of the time, do I get the marks? And yeah, we don't even know. Brilliant suggestion as well, though. I think that contains some advice that if you're running out of time, write some methods down. The kind of secret level of that advice is that before you're running out of time, write down methods. And then use your time to fill in some details. The kind of galaxy brain level is you read the question, and on the read through, you make notes or you write down ideas as you have them. And if you don't have any ideas for a bit of a question, leave a big gap. Write down ideas as you have them as you're reading the question, and then come back and actually do the questions and fill in all the gaps. I think that's the galaxy brain level. Worst handwriting. It's hard to describe, right? But handwriting I can't read. I've got really good at reading bad handwriting as a result of marking MAT for a few years. I'm the person that things get brought to. If another marker has something they can't read, they bring it to me, and I can usually read it. If we can't read it, then we can't mark it. We will do our absolute best to read what you have written. You don't have to listen to this, but please help me out. Please help me out. Right. General problem-solving tips. Should we do some of those? We've sort of got a lot of time today, I think, now that we've got going. Drawing diagrams is amazing. I think people should draw diagrams even if there's no marks available. Maybe it's how I like to think about problems, but I love to doodle little pictures or diagrams of what's going on in the question to try and help me visualize it. I've realized over the last few weeks that I'm quite visual in how I like to think about math problems. Not everyone's like this, we've found out, but I like to imagine this. So when this question comes up of are people from a wider group of n people, I'm sort of imagining like circles or sort of groups of, here are the big collection of people, here's my sort of subset, size R and n over here. I'm sort of imagining what this is, of whether, because now I can think geometrically, is Sophie Germain one of these people? Is she inside this group or is she inside this group? And that's like clearly she is or she isn't like mutually exclusive. She's either in there or she's out there. Let's define what I mean by out there, right? Anyway, can you eat in the maths? I think you can get, not by default, probably. I think normal exam rules hold. Don't actually know. I know that. What do I know? I knew someone at university who had permission to eat in exams for a medical reason. So if that's the question, then go for it. They'll get permission and request the thing. Go through the process. How big or small? Generally, we can read it. We can zoom because it gets scanned. We can read quite small things by zooming in. I don't know what font size people's writing is. The questions are written in, I think, either 11 or 12 point, if you want to compare. The edges should be okay. The very inside foldy bit is dangerous, but people don't normally write there anyway, so we should be okay. Kai wants me to mark their paper. Well, not mark it, they want me to read it. Let's be clear, I say what it says, and then the marker goes back and gives it the marks. But if you've written just like the previous case, but you've actually written just like the previous case, all one word, then maybe I have to spend some time working that out. Will I be marking? Some people are volunteering that they will write extra bad. Please don't. If anybody's considering writing bad as a joke, oh gosh, absolute disaster. Please ask your exam centre. Did I ever end up doing research on aphantasia? I found a bunch of papers that I need to read downloaded some papers. Update on my research. I've downloaded a bunch of papers that I need to read. I have looked at some of them. The research is, in some sense, not as advanced as I hoped. I think we talked on the stream about how aphantasia is not quite recognised in the same way that other disabilities are, maybe. But on the other hand, there's a society that's collecting together lots of research on aphantasia. So there is research on aphantasia, which I do need to read and understand. I've thought of a really good test for aphantasia, I think, he says. Because I think I saw a puzzle once, which was based on rotating cube models in your head. Has anybody seen one of these? I can't remember where I did it, but the questions were all of the form, here's a shape made out of blocks. There was a picture of a shape made out of blocks. One of the options is the same thing but rotated. And I think I saw a study at one point that said that the more it's rotated, the longer it takes people to spot that it's the same. As if you have some sort of rate of rotation built into your head, like your brain is trying to rotate it at some fixed rate and will then spot. So if it's more degrees, it takes more time. But aphantasia is this condition where people can't visualize things. So presumably these puzzles are all impossible for people with aphantasia, or maybe they have to use other techniques like counting and reasoning with words about where things are. I don't know, but I feel like that's the sort of problem I would. If I had a research proposal, it would be 1,000 people, and 500 of them have aphantasia, 500 don't, and they've all got to imagine rotating some things. Good. James, have you got ADHD? I don't know, not diagnosed. Not very good at moderating chat at the same time as doing a live stream, though, am I? Here's Sophie Germain. We're going to write. So this function's been written with 2 arguments inside the brackets. But note that we could write it like this if we wanted to. If this is like your personal preference of how you like to write things, you could even write it as FR instead. I think I personally prefer putting things inside brackets. Just writing them all out. It saves me from writing very small letters, especially when these things get complicated, like here. This is already a bit complicated. Multiplying things out might be better to have everything inside the brackets like that. You've got to remember that the brackets are not multiplication. I guess that's always true, but you've got to remember that, but maybe it's especially dangerous. You've got to remember it's not a coordinate system or something with commas in, but seems like quite a strange mistake to make. Anyway, this warm-up question's here because it's about explaining. I get lots of questions about explaining. We're supposed to imagine the discussion groups, that's the small group, that either do or do not contain Sophie Germain. So I suppose the most formal way to write this out is to write out a couple of sentences. I'm not going to put sentences on the screen because the writing's too slow and it's quite hard to read. But I'm going to detail what those sentences might be. This is if I had lots of time and if I was absolutely desperately sure that I wanted to get essentially 1 mark, I think probably, maybe slightly more than 1 mark. But just to be clear, what we would need to explain, we need to explain either Sophie Germain is in the group or not. These are mutually exclusive and they cover all possibilities. And then we would say if in the group number of ways is, and then in this case I've got to think a bit and I'm going to have a separate bit if Sophie Germain is not in the group, then the number of ways is, and then final point, mutually exclusive, so we should add. Okay. So this is the kind of structure of the expression we've got in the question as well. That the question looks like this, of 2 things added together for these 2 different cases. Let's be really clear again, they're mutually exclusive. Either Sophie Germain's in the discussion group or she's not. So maybe I don't know when I read the question, I suppose, that they line up in this order, but maybe the left one is cases where Sophie Germain is in the group, perhaps, and maybe the right expression there is cases where Sophie Germain is not in the group. That's my first guess. Might be wrong, we're going to work it out. So what I think we should do is to think really cleverly about the separate cases. And this is quite nice because you get to focus on the separate cases, and in each case here we've kind of done part of the work about forming this discussion group. We've got to do the rest of the work to form the discussion group. Sophie Germain on their own, not a discussion group. Let's think about that one first. If Sophie Germain is in the group, then the number of ways is the number of ways to choose, to select, I suppose I'm going to go with, I'll choose n-1 more people from the n-1, select r-1 people, excuse me. So discussion group of size r. We've put Sophie Germain in it, we need r-1 people to fill it out from n-1 other people. Okay. And that's true because Sophie Germain's in the group, I still need r-1 more people to put into the group. And I've got n-1 of them to choose from, because that's how many people are not Sophie Germain in this group. The other case here is if Sophie Germain's not in the group, the number of ways is, well, I haven't got anyone in my group so far, so I've got some more work to do. So I've got to choose r more people from the n-1 others. Okay, maybe my use of the word choose is unfortunate. You saw me regret it live, because the word choose probably reminds you of binomial coefficients, which is what this is. If I'd said select, then that would maybe I've not given the game away. Let's carry on. At the moment it's in words, lots of words on screen. This thing, I hope you can see that this first case, this thing where we are selecting r-1 people from n-1 others, that by the definition in the question, the notation of the question, that is f of n-1, f of n-1 comma r-1. And because that's what f means, it's the number of different groups that we can form from that. What we'll do is we'll form a group of size r-1 from those n-1 other people, and then we'll put Sophie Germain in it. So that's what that is. And this second case is precisely, we need to choose n people. No, we don't. We need to choose r people from the n-1 others to make the whole discussion group without Sophie Germain in it. So those are the two cases. So it turns out my intuition was wrong. The two terms are actually the other way around. But hey, this addition is commutative, so we're fine. We've got to the right answer. This thing about adding them because they're mutually exclusive is the important part there, as well as identifying in each case what the things are in terms of f again. So on the left we've got this statement about f, the number of groups you can form for the big problem with n people choosing r of them. And then on the right we've got two ways to look at this. Either the group has Sophie Germain in or it doesn't. Or more accurately, either the group doesn't have Sophie Germain in or it does. So Denim's got a more direct way where you say, I know what f is. F is the function n choose r, and this is true for n choose r because of some factorials or something. You can rearrange the factorials and it just works. That's true, not quite in the spirit of the recursion sort of way of approaching the question. I'd give you all the marks. I think. As long as you mention Sophie Germain in there somewhere. Good, because there's this instruction by considering separate cases that do or not do not. Okay. N is the total number of people. Discussion group of R people from a wider collection of N people. This wider collection is the big group. Okay, good. Sophie Germain is brilliant. If you don't know who Sophie Germain is, you're going to have a great time on Wikipedia when this is over. Or even now, if you would rather be reading the Wikipedia page about Sophie Germain. It's one of the, it was a featured article, I think. It's a really good Wikipedia page. Spare paper for questions we aren't answering? Yes, you can. That's free real estate. You can go for it. Answer stuff there. We scan all of the booklet for everybody's booklet. booklet, and then we look at it to work out what you did and mark as appropriate. So we will work out what you've done. It's halfway through. You've still got to do a question 5 and a question 7. Yeah, okay. Good. Last one here, we've got some sort of expansion. I think this one's easier to work upwards, to use this expression to work out terms from the previous ones. C naught is 1. This sum is a little bit odd. I just want to work out the first term with you to show how this sum is a little bit odd. If you plug in n equals 0 into this crazy expression, then you get on the left C1, and on the right you get this slightly odd sum. This is a notation for summing things, which you might have seen. It means start at the number at the bottom and plug that in for I. Work through the numbers until you get to the number at the top, and add all of those things together. This sum starts at 0 and it also stops at 0. So this is just the sum C0, C, oh that's a 0 over here as well, C minus 0. Minus 0 is the same thing as 0, so this is just C0 squared, which is just 1. So the first term's a little bit weird. It gets less weird after that, because then when you plug in n equals 1 into this expression, on the left you've got C2, and on the right you've got maybe the sum makes more sense when you write it as C like this, 1 minus I or something like that. I mean 1 minus I? Maybe I've written this all completely wrong, but hey, I think I'm doing okay. Good. Okay. If you write a correct method and an incorrect method, you should consider crossing out the incorrect method, please. Good, okay. There's not a complex I. You want loose paper? Yeah. Hard as this scan. See what we can do for the future. Not for this time. This time it's booklet. Sorry. Go to the printers. Please answer in the booklet. Gosh. Okay. These are famous. Can we conjecture that C subscript is 2 and is odd, even only if C subscript n is odd? Yeah, okay. I feel like we're going to get there at some point in the long questions, which I think we should get to. Should it say 1 at the top of the sum symbol? Maybe it should. That makes me much happier, actually. I was really worried about C negative 1. Yep, thank you, Bradman. Yep. I can't plug in 1 properly. G'day. There we go. Can you just use elimination in multiple choice questions? Not always. I mean, sometimes you can, but you can't always use elimination. If you want to use elimination, go for it. Sometimes I suppose you have to, because it'll say which one of these is the biggest. That's the past question we've had. Which number is biggest, and then you've got to eliminate options because there isn't just an answer to that question in general. Oh, what was C2? C1 and C2? Oh god, yeah, I didn't actually finish working that out, did I? C0 C1 plus C1 C0. Never finish anything. 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. C3 is the sum from I is 0 to 2. Ci C2 minus I, which is C0 C2 plus C1 C1 plus C2 C0, which is, oh goodness, C0 C2 is, you kind of sandwich the sums together, reading in opposite directions. That was a terrible thing to say. That doesn't make any sense at all. That's 5. And then I've got to do one more. Sum from I is 1 to 3 of Ci C3 minus I. So as you write down the terms, the I starts at 0 and it gets bigger. And the C3 minus I starts at 3 and gets smaller. C1 plus C3 C0. Gosh, that's the messiest thing I've ever done. Can I write in handwriting so bad that I can't read it? That's when you know you've got a problem, when you can't read your own handwriting. I think that's when it gets a little bit problematic. That's 5. That's 1 times 2. It's 2. That one's also 2, and that one's also 5. These sums are quite nice. And that's 14. These are called the Catalan numbers. There's more information about the Catalan numbers in the extension at the end of this sheet. Good. Is there any advantage to showing the working? Well, showing you working, you're encouraged to do it, because then, I guess, we can see what you did if we want to. It's quite unlikely that we're actually going to go through and look at in detail at your working up for the questions there. But if we want to, for example, if we want to see was this person, maybe they're wrong, but they were very close to being right, perhaps. Can't really tell that from the multiple choice score, but we could go and look at the working out, see, they're very close, they made a minus sign mistake, we saw. You don't actually get part marks but sometimes they could go. It's half time, everyone drink water. Oh, good times. That building work is finished, which I'm very happy about. What's the best soft drink? Obviously water, if that counts. Thank you to the anonymous person in chat who is keeping everyone hydrated, including me. Jack continues to be a fan of this water bottle I bought. It's too big. It's too big. We're getting Daisy on a different day when I've worked out how to capture audio from Teams in particular. It is a Teams interaction. While we're in the halftime break here, halftime hydration time, modern programs like Zoom and Teams do a lot of strange hardware acceleration that I don't understand, which bypasses some bits of it makes them harder to capture. It's harder to record it's harder to record a Zoom call on here than it is to record Firefox or something. So that's a bit complicated. Right, half-time break. There we go. Am I in the Andrew Wiles building currently? Yes. This is my office in the Andrew Wiles building. I think my office. This is the outreach office in the Andrew Wiles building. More blank sheets. It's too late for me to do it this year, but point taken. Yeah. I want Daisy back. I also want people to be able to hear Daisy. Us spending maybe another hour now trying to work out how to capture audio from Teams is, I promise you, even less fun than what I'm actually about to do, which is 2 math questions back to back. Let's go, 2 math questions. I'm also going to switch on the lights. No, we're going to do this in semi-darkness. No, the lights plan was a good plan. The thing about having tech trouble 5 minutes before going live is it also replaces the 5 minutes of preparation before going live that we might have. I've met Andrew Wiles a couple of times. I'm not sure he would want to come on the live stream, if that makes sense. It would be amazing if he did. Maybe. It would be amazing, wouldn't it? Maybe it would be worth it. Cool, good. Right, let's do this rhyme scheme question. I think it's enough half-time break. Is it a diss? Is it a diss? It reads a little bit like a diss. Right, okay, rhyme schemes, let's go. I love a question with a bit of reading at the top. This one's trying to define a thing, not quite a maths thing, I suppose, but it's trying to explain something to do. Maybe it's... I know that reading during a maths exam doesn't feel great because you're not doing maths. That's actually quite normal for maths, that maybe you won't be writing constantly for the thing, that you'll be trying to understand things at the same time. We like to give you maybe something to try and understand in some of these questions. Good. Good way to prepare for the test. We should do some questions. I'm going to do the question now, Paolo. The question doesn't appear in there. There it is. Paolo, hi. We're going to do some math questions. Okay. Here's the definition of rhyme schemes. I need to read all of this to make sure I understand it, because that will really help me do the rest of the question. Each line is denoted by a letter of the alphabet. Okay, I know the alphabet. With the same letter given to 2 lines that rhyme. Okay. So if lines rhyme, they get the same letter. Okay, right, good. More precisely, the first line of a poem is given the letter A. If a subsequent line rhymes with an earlier line, it's given the same letter. Otherwise, it's given the first unused letter in the alphabet. For the purposes of this question, there's a little disclaimer in brackets. You can assume that we have an infinite display of letters, not just the 26 letters of the alphabet. That's such a mathematician thing to say. I hope that doesn't matter. The purpose of this question is to investigate how many different rhyme schemes there are for poems of n lines. The people like this sort of thing, by the way. I'm on the fence, I think. I've considered in the past having more long questions that start the purpose of this question, or this question is about. I don't know if it's helpful or not, because there's more reading to do, but it also tells you what's going on. Anyway, there's a definition here of Rn to be the number of poems with number of different rhyme schemes for poems of n lines. So as soon as I see this, I want to look at small numbers, because I've got a feeling this whole question is going to be about R. That's not actually true, it's mostly about C, but hey, I want to understand R. I suppose R1 is equal to 1, because there's only one poem of length 1. It doesn't rhyme with anything, it's just sort of one line. R2, I suppose, is 2, because it could be 2 lines that don't rhyme or 2 lines that do rhyme. Now I'm thinking about powers of 2 and whether things agree or don't agree, but maybe that's not right. because I've just seen the first part of the question here. There are 5 different rhyming schemes of poems of 3 lines. So I was about to get there, but maybe not. Feels important to me that we do this alphabetically. I'm not quite sure why, but it just feels like when I was writing these 2 out, I felt maybe I should have listed them the other way around. Repeating letters feels like it's going to be easier to think of the ones that repeat. Let's think. So 3 letters, they could all be the same. Let's see if chat can find any more. What should I do if I'm stuck on a MAT question, looking at the mark scheme and still confused as the solutions are very bare? For recent years, we've tried to put more detail by making a big video that goes through the solutions. I'm trying to work my way backwards, but it takes a long time. Firm out on the live stream. Distracts me from part A. Right, okay. Distracts you from actually doing the question to be reading about what it's about. That's fair. Okay. There are some suggestions in chat already. I'm going to approve them without reading them and see what happens. Cool. So people are just shouting capital letters at me, which not the first time. Let's see if we can piece them together. People going in. Revel's got 4 of them, and then which constant is that? 2.50662827. Whose constant is that? Vaguely familiar. Is it related to gamma? No, gamma's 0.5-ish. 77. More suggestions in chat coming. If the question revolves around the clarity, Maclaurin series lover says if the question revolves around a quirky concept, for example, some sort of Maclaurin series maybe, the purpose statement is beneficial. Okay. Balance. If it's a very short sentence. This one is it's the definition of Rn as well, so it's semi-useful. Yeah, different branches. I like the branches. Branches feels like a geometric kind of way of thinking about these poems of 3 lines. I suppose we could start bringing in different letters, right? So the next alphabetical thing would be this, and then maybe I could think about this. I think that's allowed. I think this is a rhyme scheme. I'm just using 2 letters so far. Yeah, okay, maybe my system is I think about 1 letter first, and then I think about using 2 letters, and then I think about using 3 letters. Maybe that's my system. I found 5 things, so I'm going to stop now. It doesn't say to list them in any particular order, so I think I'm good. Does it give you most of them? Oh yeah, look, here are 3 of them just written in the question. That's a bit of fun. I've thought of a terrible method to make sure we get all of them. I mean, they tell us there are 5, so we're not gonna mess it up. I've thought of a terrible method for working out all of them, which is there can only be 3 letters here, so there's only 3 to the power of 3 possibilities that I could write down, and then check whether each one makes sense or not. There's like a finite amount of work, right, to work out 3 lines. You're going to write down 3 letters. Those 3 letters could either be A, B, or C. There are 27 possibilities. Only 5 of them actually count following all of these rules up here. Terrible methods, but feels like I could give it to a computer and the computer would just go for it. Not a good strategy for the question, but hey. I think, does this question end up with us calculating Rn? Not quite. Not quite. Finite amount of work is, yeah, okay. Raphael says it's not a very high bar, which I think I accept. N to the N is not a very good complexity rating if you're into that sort of thing. New question, and this one's actually brought in the 2 subscripts thing, which I would personally prefer to write as this. I think myself, if it was me, with brackets and commas, it means that sort of the same, but everything's going to be quite small down here, but which is fine. It just gets a little bit messy around here. You have to remember all of this writing is small in the subscripts down there. Anyway, I guess we avoid drawing any brackets, so it's less ink on the page. I see, so this is going to be the poems of length n that use exactly k different symbols, which is the way I was splitting it up over here. So C32 is the number 3, and it corresponds to rhyme schemes with 3 letters that use 2 different letters. Okay. Good. Okay. explain your answers. If you can't join the live streams, then I'm not quite sure how I'm going to answer your question, but you could send us an email. Ooh, okay. Suggestion in capital letters. I told you people put things in capital letters. Input of function. Never seen subscripts in functions in A level. Okay. It's supposed to look like a sequence, I suppose, but with commas. It's a strange thing because it looks a little bit like matrices as well. And matrices are not on the MAT syllabus. So, I don't know. If you've seen matrices, maybe you're really happy with this sort of tabular thing. If not, then hey, we've seen it now. Same idea, but written small in a subscript with a comma. The comma is to make sure that you know this isn't the number 32, that it's 3, comma, separately 2. Anyway, let's do the first parts of these questions. These ones I love because they're like very small. You're probably going to get about a mark for each of these, maybe 2 if you do the explanation as well. So CN1, when n is bigger than or equal to 1, we've got a poem that has n lines. I like to write it out, but only one letter. That is one poem. That is, which is maybe how you feel about this question so far. I think I do that joke every time. I think this is 1. CNN has n lines. N lines and uses n letters. So this is the poem where nothing rhymes. And I think there's only one way to do that as well. If n is bigger than or equal to 1, yeah. If n is 0, then you don't even have. Is there anything bigger than or equal to 1? I don't know why it says n bigger than or equal to 1 here, but then not in the next part. Anyway. Yeah, people in chat joining in as well. Yeah, Miro just like updated itself or something. I wasn't looking. Did anybody notice any upgrades? Did it change? Did it get better? Has it got like superpowers now? Oh, conjecture. Yeah, so something I quite like here is that down here, if you read ahead in the question, we're going to work out. So we're about to do a part of this question that relates C and K back to other versions, other numbers of C and K, like we did earlier on, explaining with Sophie Germain. We're about to do that part, but then later on, we're going to relate this back to the RNs, and we're going to give a formula for CN2, which I suppose is the number of poems with n lines using 2 letters. That doesn't sound too impossible, by the way, compared to the ones we just did up here. They were sort of fine. And then this one down here doesn't sound that terrible. I just want to see how it's going to work, right? We've got just 2 letters. We've just got A's and B's. But not all A's, right? I think so. I scribble something like that down the first time I read the question. Then when I come back to it, I'm now doing an easy version of the question because Past James has written some helpful hints on the question for how to approach this. Okay, we'll come back to that later on. But maybe if you want to skip to that and think about that one, then maybe that's a good plan. Okay. Oh, someone's done this one recently. I was also going to put a note down like powers of 2. Oh, I don't know how I would mark this now. I have to think about that. Prompting is good. This is a good sign. The very first aeroplanes that we built needed a bit of help. They needed to roll down the hill and go over the bumps, and when they go over the bumps, they would get up in the end. But it wasn't long after that we had planes that would take off on their own. This is a good sign. It means you're close to takeoff. Is each sub-problem worth 3 marks? Not always. Some of them worth more or less. Sometimes. Yeah, no multiple choice, because we don't have recursion in a multiple choice question in the years that I'm using. There's a lot of restrictions on how the live stream works. Could you just put K? So they want it actually in terms of just in N's, not in terms of the C's. Could be wider. If you just stick 2 into the expression from 3, I think I'm not going to accept that as an expression in terms of N, because it's in terms of C's as well, and you don't know what the C's are. Anyway, or maybe you do. Maybe you do. Oh, there's an interesting idea there as well, actually. I'm going to write that down. Maybe that goes somewhere. Good, right, we'll come back to it. Because we've got an explaining part of the question to do, can you use sigma notation? Yeah, if it's some that you can do, then you might be missing out on a mark by not doing the sum. Maybe we want to give you a mark for actually doing an arithmetic sum series, or maybe we want to give you a mark for doing a geometric series. So don't leave that mark on the table. Good. Yeah. Have we done part 4? No, we skipped it. We read ahead. This was our clever thing that we were going to do. We were going to read ahead, write down some notes of how we were going to do the question. This thing about R's in terms of the C's sounds like you just add them up, right? I guess that's why people are asking about sigma notation. You just add them up. We're working inwards. Rn is something like, I guess sigma notation would be fine for this, right? We don't, at this stage, in part 4, we don't know these. We want to add them all up. So I think I would go for something like this. K is 1 up to n. We want to add all of them. And then it says hence calculate R4, but I don't know in the C's at the moment. So I could write it like that, or I could write Cn1 plus Cn2 plus ... plus Cnn. You want n lines, and for the overall Rn number, we don't mind how many letters you're using, so all those possibilities added together. Okay, when did we do part 3? We haven't done part 3 yet. We are working towards it. Or towards it, working inwards. We haven't done part 3. This has thrown everyone. Everyone in chat is like, oh my goodness, what happened to part 3? Part 3 is coming after the break. No, we already had the break. We haven't done part 3. That's pi, right? That was pi. I know that number. Is it pi but with 1 digit changed? Anyway, let's not get distracted. Let's do part 3. And they give us a way in here. They say, by considering the final letter of a rhyming scheme. And I suppose what we need to realise is that a poem, in this question, is merely a shorter poem with an extra line on the end. I don't know if that's how poets actually think about their work, that you remove the last line and you have a poem, but in the confines of this question, a poem without the last line, or is just a shorter poem, maybe missing its punchline. Did we call them punchlines in poems? Maybe not. Why did we go ahead? So confused. I like reading ahead to find out what's going on, right? Don't worry, we'll go through. We're going to be alright. Yeah, so whether or not. So, okay, so on the left here we've got CNK. This is a poem. We're thinking about poems of n lines using k letters. And I suppose if you're getting ready to say the last line of a poem, maybe you're making it up as you go along, you've got 2 choices. So this is how I want to structure it because of the plus sign in the middle. I'm thinking about these 2 choices. You can either, the final letter is either something new or it rhymes. I suppose I could word that it either rhymes or it doesn't, to make it clear that I know that these are mutually exclusive. It's one or the other and not both. So the explanation needs to give enough detail that it's only enough detail that it's clear that you have had the idea about what's going on here. This is a little bit difficult, but you shouldn't worry about it too much. If you've worked out what's going on, you will probably write down enough that it's clear that you know what's going on. If you don't know what's going on, then don't try and cheat. Try and think about the question instead. Good. So here I've got this idea that the final letter is either new or rhymes. There's not a lot of detail in that sentence, but I think it's already worth credit, already worth a mark, if I say so myself. Where that's it. That's the core idea of what's going on. Now that's, I suppose a different approach would be to say that the final letter is either A or B or C or D or the nth letter of the alphabet. Didn't love saying that. That felt really strange to say. The nth letter of the alphabet. And I don't mean N. Ugh. That's made me feel very uncomfortable indeed. Okay, so alphabet aside, the final letter is either new or it rhymes. If it's new, in that case, then we must use the next letter, the next unused letter. And all we've really done is we've got a poem of length k-1. No, we've got a poem of length n-1, and then we've got a random line on the end. It doesn't rhyme with anything. It's just sort of non sequitur, extra line on the bottom that hasn't rhymed with anything at all. So each rhyme scheme like that consists of a sensible rhyme scheme so far for the poem so far, plus just use a new letter for this extra line at the end that doesn't rhyme. Which might say that for each of these, there's one poem of length n-1 that uses k-1 letters. And that's why the number of these, number of such rhyme schemes, is exactly c(n-1) k-1, because that's the number of poems that are one line shorter and use k-1 letters, and then finally this kth letter appears at the bottom. Okay, good. Oh, I've realised I did that bit about the nth letter of the alphabet, and I maybe meant the kth letter of the alphabet. Ah, well, never mind. BRB, just going to go and put "that was actually quite funny, James" on my tombstone. That can go on my tombstone. Good. What am I doing? Okay, right, good. We've justified this term here. This bit, I think, corresponds to last line doesn't rhyme. Vote in chat. Does the phrase last line doesn't rhyme, does it rhyme or no? I feel like it's close. I've written it in 2 lines so that it looks like a little poem. Right, anyway, let's think about the other case. If it rhymes, it's got to rhyme with one of the previous lines. Well, I suppose one of the previous lines. There are n-1 previous lines, but some of those might have repeats in, and it's easy to get really confused at that point and think, oh gosh, I've got to think separately. Within this case, maybe I've got to think separately about separate subcases depending on whether it's rhyming, whether there's 7 letters there or 6, because then how many possibilities are there? Is it n-7? Oh my goodness. But no, the actual number of cases inside here, the number of things it could rhyme with, is precisely k. For which letter it is. I know because there are k letters in my poem overall. The last letter is going to repeat one of them. There are k choices for what that could be. Okay. So this case is slightly different. Here we have a choice to write out a poem with n-1 lines and k letters in this time, because we're going to reuse one. But then we've got a further choice of which one of those k letters are we going to repeat at the end. Am I going to rhyme with A? Am I going to rhyme with the line that was labelled B? Am I going to rhyme with the line that was labelled C? Or so on down to the kth letter of the alphabet. Those are k possibilities. In each case, you take a short poem and you put a line on the end. But now you take that shorter poem and you have k different things that you can put at the bottom, and they're all different rhyme schemes. So in this case, we need to take the number of short poems and multiply by k to allow for all our choices at the bottom. Good. Rhyme. But with what? So there's something really subtle going on here as well that if you find this very surprising, you should think about. You should think about it anyway, I suppose. When the things were mutually exclusive, we added together the possibilities to say, on the one hand, either the letter's new or there's a rhyme. That's when we added. But in a separate case just now, I've said that you should multiply by the number of choices. Those two things sound very different because in one case I've added and in one case I've multiplied. It is actually the same logic underneath. If you find that surprising, you should think about the possibilities of what that is and being a bunch of adding between different subcases. Maybe that's helpful enough to write. I don't quite want to write it out because the notation's wonky, but you can imagine there are k possibilities. I know. you can imagine writing out each term, and they all happen to be the same thing, so it's been condensed down. But you can imagine writing out each term with add signs in. Good. How do we know they're mutually exclusive? For the first bit, we know they're mutually exclusive because we can always tell from a rhyme scheme whether the last line rhymes or not. All the cases in the first case are ones where the last line does not rhyme, and all the cases in the second case we described are ones where the final letter does rhyme with something in the previous one. So there's no way we could double count something, there's no way we could miss something, because it either does or it doesn't. Those are the rules of counting. You've got to make sure you don't miss anything and you don't count anything twice. Those are the 3 rules. Right, okay. So once again, my cases are the wrong way around compared to the statement. Just the way I thought of them is different from the order of the question, but hey, good. There is now a boring part of this question where we try and actually work out the values. So Rn, this total number of poems with n lines, well, we don't care how many different letters are used. We have notation for that. We say it's Cn1 if there's one letter. We say it's Cn2 if there's 2 letters. But we don't really care if we're just trying to work out Rn. We want to add all of those things together. Either you use 1 letter or 2 letters or 3 or k letters, which was way back the system that I was using earlier for either all A's or A's and B's or mixed of A's and B's and C's. We need to add those things together, like how we did 1 plus 3 plus 1 was 5. Here, if we add them all up, we will work out R4, I suppose. Well, I suppose there's a step in there that I know that R4 is the same thing as C41 plus C42 plus C43 plus C44, and now I'm faced with a bit of a challenge to actually go and work out what those things are using, I suppose, that equation from the previous part. So I can plug in values in here, and it's going to be a little bit messy because when I plug in values, it's going to recur down to other values, involve other values of C, maybe C3 comma something, C2 comma something. I'm going to keep going until I get down to things that I recognise. I suppose I remember that I know some stuff around here. That's the way where you work backwards. If you want to take this expression, expand out the R4 into these C's, and then expand all the C's and try and bash it down to something you recognise. There's an alternative where you build upwards, that you work out C for small values of n and k. You work out C and k for small values of n and k, and you use the information that you've got to piece together the values. We've seen that working both ways around for the Fibonacci numbers earlier, and now we've put it here for you could build maybe a table if you wanted to. There's notes in the revision section in the warm-up section for how you might build a table for what C and k is for different values of n and different values of k. But you could do it either way around, I think. Okay. These first, so the first and last terms are both 1. You're correct. That's what we did in part 2. This thing is 1, and this thing is 1. And then we want to do these other terms as well. So the tricky thing to work out here is going to be C42 and C43. We will need to plug in some values as well. Someone said this is why more space is needed on math questions, and I should stress that for an actual math question, you get some space. I'm trying to keep the question on the screen. In real life, you get a whole booklet, you can open it, you can write on a different bit of paper to the bit the question's on. There's a sort of live stream artificialness here that I'm trying to show you the question and also answer the question by writing on the question. Not how you would approach this question in the actual test. Of course, you would write in the space. Okay, what was Rn? Someone asked. I think Rn was the total number of rhyme schemes of length n that use k different symbols or letters. So there's what was going on there. I mean, we don't care how many you're using, so add up all the different values of k, all the sensible ones. Good. Matt Livestream's all fake. Yeah. It was all a dream. It was a really weird dream where none of the technology worked. Okay, very last part here. I've written a note for myself. That was nice of me. Formula for Cn2 in terms of n. Justify your answer. I've got n lines with 2 letters. That's what that means. Just A's and B's, not all A's. Maybe powers of 2. Feels quite powers of 2. I've got these choices about whether A's or B's. I've also realised this time round that the first letter must be A. That was one of the rules. Must be A. Then everything's either A or B. So I guess it's like 2 to the power of n minus 1. You just make your choices. Just go for it. Knock yourself out. You can have some A's or B's through there. Oh, but I suppose you could have not all A's, so subtract the one case where you wrote down loads of A's. But otherwise, think about everything. Yeah, in 2020, I added an extra double blank page for solutions, for writing out solutions. So if you look at the past papers, there's extra blank space throughout the booklet. We rearranged where the blank pages were, so that we weren't using extra paper, but we were rearranging the paper. Gosh, I would think we've got there. So I got this by thinking about just choosing A's or B's to just freestyle write out my poem by I've got to start with an A, but then going for A's or B's afterwards. I'm not allowed to write down just A's. That would be a poem with one letter. Okay. Have we actually solved 4? I think I didn't follow through on question 4 to actually work out these things. Oh, excuse me. Actually work out these things using using smaller values. It's a lot of adding. It's a lot of multiplying. Didn't want to do it on the live stream. Homework. Please try and plug in the numbers. Is it clear what you would do by plugging in the numbers? Let's do a tiny bit, a very tiny bit. I want to move on to the other question as well, because even if I haven't finished this question, I have got a little bit bored of it. So here I would write out something like C2 3 2 plus C3 1. Okay, because I plugged in N and K. Nobody wants to watch me do 5 of those. That was painful to write. It was painful to listen to, I'm sure. It'll sound like battleships of just me saying letters and numbers. Why minus 1? Which minus 1? Minus 1. This minus 1 over here. I reckon you mean this minus 1 over here. And that's me subtracting the one that's all A's. Exactly corresponds to that idea. You can freestyle your choices of A's and B's, so long as you don't pick all A's. That's the only banned one. Do we know the values of all the C3s? Oh, maybe we do from earlier. Maybe we do. Yeah, we worked them all out. This one was 3. No, this one. We worked them all out. I've said that too many times in a row. Yeah, that one was 3. We worked it out earlier. That one was 3 and only 1 letter. That's one of the ones that's 1. Oh, so this is 7. Oh, I actually think we're now going to do the question. Bad news, everyone. I've got confident. K is 3. This term over here. Confidence always means that I just instantly complete loss of any sense that I can get anything right. There we go. That's 3 again. This one is 3 times 1, so this one's 6. So I think I want to do, is it 6? C32 was C32, 3 letters, 3 lines, 2 letters is 3. Good. I've got 6 this time around, which I don't feel like I recognise as a number. But hey. My final answer is going to be 15, which doesn't quite feel right, but never mind. Good. Has this phrase got a double meaning that I should be aware of? Maybe I should stop saying that phrase. Good, okay. We're going to do a different question, which is all about drawing lines and making shapes, keeping everything together. How do you integrate which question you are doing if you use the free real estate question 6+? We will be able to work it out because we know what the questions look like and we know what your answer is roughly going to look like. If you want to help us out, you could write the question number in the top left with a circle around it. You don't have to. That's not a rule about how the mat works. That's just how communicating to humans. You make it easier for us if you say Q5, put a big circle around it. Well, I guess this is some question 5 then. You don't have to. We will work it out. We know what question 5 looks like. If you've drawn a bunch of these, then we're like, I'm pretty sure that's question 7. Good. If you're not doing question 7, then you might enjoy this anyway. In the sense that what we're going to do is another explanation of what these cases are, and I think the explanation is maths somehow. Like in a really deep sense. The explanation of where the terms come from is maths, and then the recursion of how it actually fits together is maybe closer to computer science or something. I don't know where I draw the line. Yes. Right. Okay. Maybe that be as poetry advice in chat. B either being or not being the last letter, and A being the first necessarily. You get a whole bunch of them. First few values. I think the number of values grows way faster than that, because there are lots of possibilities for the in-between letters. The letters in the middle of my poem could really be anything. A's and B's, they could be anything, right? Maybe I've got an A at the front and a B at the end. Well, maybe not actually, but maybe I've got an A at the front and a B at the end, and then loads of stuff in the middle. Way more than n squared things, because I've got n minus 2 letters around here. They can all be A's or B's. It's got to be massive, right? Carl wants to know, did we do this question on a different live stream? Carl, we did this question exactly a year ago on the MAT live stream, but that's true of most of the questions. So it's quite memorable, I guess, because it looks like this. We're given another definition of some things. 23 minutes, bit of a push. Reckon we'll be okay. Let's go. So we're given a definition. There's an n fan, n points over here, n points over here. To get another 1 point, this is the hub over here. It's not on the line, okay. The end tips are joined to each other and to the hub with line segments. The picture on the left hand shows a 6 fan. Brilliant. I am not a 6 fan. On the right, there is some stuff. What is this? Given n fan an n span. Oh my goodness. This is a 6 span. There's a subset containing all the points and n of the line segments chosen so all the points are connected together with a unique path between any 2 points. Oh my goodness, okay. The right hand picture shows one of many 6 spans obtained from a given 6 span. In this 6 span, the tips are in groups of 3, 1 and 2, with the top group containing 3 okay. These are groups. Okay, lots of words, labelling pictures. Does it say I'm so sorry to the person who I read it as a quadratic. Oh, I'm so sorry. And then I explained it wasn't a quadratic. But that was pointless because you hadn't written a quadratic. I just read that wrong. I've gone up slightly so you can read the question. You can bring rulers, protractors and compasses to the exam, so long as, to get it out of the way, so long as they are not also calculators. Good. Right, okay, we're going to draw the 2 spans. The 2 spans have, I suppose, 3 points in them, and they need 2 lines. And then there's these rules about making sure that everything's connected, making sure that it's only connected one way. Unique path from anything to anything else. I think any connection for these 2 spans seems to work. I put my 2 lines in, all looks good to me. This thing about 3 spans, well, I suppose I should start just having a go at it. I've got some space over here which I'm going to use for my 3 spans. I like these ones where you have to think along the way, how are you going to systematically work through this? I've got to draw 3 lines, so I've got to connect everything to everything. The obvious one, or the one that feels obvious to me, is to connect everything to the hub. I think that's allowed because there's a unique path between only 2 points. So this seems pretty good. So that's one of them. I reckon that's always one of them. I don't know if that's relevant or interesting, but just like if I'm asked to draw a lot of spans, then it's going to be one of the ones I draw. I also kind of like starting with, is the top line there or not? I don't know. It just feels like something that is there or isn't there. I'm always looking for these kind of mutually exclusive ways to break down the problem. I don't know if that's the one I'm going to stick with later on. I've still got to connect the other 2 points. I suppose I can connect this one. I can connect to the hub. I kind of just did that. Let's do that again, and maybe I'll think about this one. I'll connect not to the hub to make it different. Okay, I liked that. There was a choice there of either, within the top line being like that, which I've drawn again. There's a choice there for either the bottom one goes to the hub or not. So maybe I can think about that on the middle one instead. Maybe it goes to the hub, or I've done a couple whether it goes to the hub. Maybe I could do one that doesn't, and then I suppose I've got some possibilities there within this. So it's starting to feel like powers of 2 or something. Okay. So do I think these are all the ones where there's a line at that top diagonal line is there? Feels like maybe it is, because I worked through doing, does the bottom thing connect to the hub or not? Does it connect to the hub or the point above? And the middle one, does that connect to the hub or not? And I've gone through all the possibilities like that. Have I missed? Yes, I've missed the one where the middle point connects down and then this one connects to the hub. Oh, that's annoying. That's not fit into my mental model of how this works at all. But hey, I have spotted it and drawn it. Good. What if the top line's not there? Then I suppose this one has to be connected like this. And then at the bottom, this looks like what I was doing before with 3 points to connect. So I can draw these in like I had them before. There's quite a lot for ways to draw this. Okay, that made me feel better that if the top connects downwards like this, if this diagonal line here is not here, then the top one must connect downwards, and then I've got this sub-problem below, which I recognise. That feels recursive to me, but this sub-problem below, having these 3 points below, I recognise that. Good, feels like decision maths because of the paths. So someone in chat, I suppose. One similar to the second one. Similar to the second one. I think they're telling me that I missed this one out, which I did. So, kudos. I feel like I've now got all of them. I've got 8. It hasn't told me how many there are. Think about which lines you erase and then adjust those. Oh, I see. Okay, so you're going to erase 2 of the lines, and it's not always. You can't just erase any 2 of the lines, because if you erase both of the lines that connect to the top point, that's trouble. And if you erase both the lines that involve the bottom point, that's trouble. But otherwise you're fine, aren't you? Oh, I've drawn all the other 8. Huh. Okay, so this is 5 choose 3 minus 2 or something. Okay, interesting. Cheerios, great. Really like Cheerios, or at least I don't eat them anymore, but good. In favour of Cheerios. Other cereals are available. Yeah, okay, so I like that suggestion from chat. Who said that first? There's an anonymous person on screen. Think about erasing lines. You erase only one line and then think about what you erase next. Either you erased one of these critical lines that supports one of the extreme points at the ends, or you erased something a bit more safe on the inside. Okay, I wonder if it's going to work like that. The number of lines we erase is going to go up. I wonder if it's going to work like that for bigger numbers. Okay. Yeah, so it's like 5c2 minus 2, I think. We subtracted 2 because I didn't draw the one where you missed the top 2 lines, and I didn't draw this one where you missed the bottom 2 lines. So 5c2 minus 2, but I don't know if that continues. It's just this 5c2 minus 2 is just another way of writing 8. I'm not claiming it continues like this. Just this is one way we could maybe have got to 8 by thinking about subtracting off those 2 possibilities where you these 2 kind of band ones. Let's draw the band ones in a different colour. Where I draw 3 lines but I fail to connect to the top point, or I draw because I've removed both of these top ones, or I draw these lines but I've removed both of these bottom ones. Okay, they're banned. Right, part 3 says, by considering the possible sizes of the top group of tips, I haven't been thinking about groups of tips, and how the group's connected to the hub. Okay, calculate the number of 4 spans. Okay, so I want to write down, I think, anything I can about considering the possible size of the top group of tips. Top group of tips. So it could be size, possible sizes. So top group of tips, what do I know? It could be 1, 2, 3, or 4, right? That's what this means. That's 1, 2, 3, or 4. Because the top group could just be 1 point, or it could be all of them, or something in between. Those are sub-problems. I guess I can think about those sub-problems one at a time and try and work systematically through them. It's not what I was doing before, but okay. So if the top group is size 1, then I need to connect that to the hub, because it can't connect down, otherwise it would be a group of size 2. And then I've got 3 more points that need to connect. Oh, I see, they need to connect to each other and to the hub, and they cannot connect upwards because we've said how big the top group is. I see, and that is the number of 3 spans. Have we got a name for that? Not yet, but it's going to be Z3. I see. So they're going to be, when I try and connect up the rest of this network, that's precisely the problem we were just doing in part 2. So there are 8 ways to finish this off. To complete it. Or I can do a top group of size 2. I'm working through my possibilities. If the top group is size 2, then I've got my group of 2 here, and then I've got 2 more points, which can't connect upwards. So they have to connect somehow to each other and the hub. And this bit at the top has to connect to the hub. I see, okay. So I've got 2 possibilities for how the hub goes, and I've also got 3 possibilities for how to finish off the picture at the bottom. Those choices are independent, so I should multiply. I've got 2 choices for how to connect the top group, and I've got 3 choices for how to draw this picture because I've spotted it's the same as the picture in part I. 3 ways to complete, and there's 2 ways to connect the top group. Either it joins to the top point or the second point, I suppose. Okay, if the top group is size 3, now how many have I got so far? I've got 8 from the first case, and I've got 6 from the next case, and then I've got I don't know and I don't know. Okay, if the top group is size 3, then I've just got 1 point left over. So I should join, there's 3 possibilities, 3 ways to connect that to the hub. Connect that top to the hub, and then 1 at the bottom here must connect to the hub directly, because it can't connect up to this group. We've said how big the group is, it's size 3, so this one's going to have to go to the hub. One of these ways to connect that top group up, and we've got to connect the bottom group. Okay, I like this way of thinking. Last case, there are 4 points in the top group, which means it's all of them, and I've got 4 possibilities of how I join up to the hub. Ways to connect this group. So this is just going to be +4 on the end. Okay, so that felt quite systematic, I suppose. That is 21. Good. Chat's not going very well there. It's not. Oh no, hang on. I see what's going on. Good. Can you request square paper? If you need square paper as a disability support thing, then I don't see why not. As a normal way exams work, no, not as a normal. There's no reason there would be any squared paper in the room. So if you request it in advance for some sort of reason, then maybe, but don't expect there to be squared paper. Cool. Okay. I feel like by working through this, thinking about the ways to connect the top group and the ways to complete the graph, I can sort of see what this relationship is. They've asked for Zn, the number of n spans, in terms of the previous ones. I'm going to write down what I'm thinking, and then talk about what I'm doing. Talk about what I'm doing as I write it down. I think Zn is equal to, the top group could be size 1. If the top group's size 1, then you've got to join that to the hub and then sort out the rest of the points. Sorting out the rest of the points means the previous problem that you just did, where you want to connect up n-1 remaining points. I don't care how you do it, so pick any of the possibilities, join that top point to the hub, like a poem with a bonus line. But there's this other case where maybe the top group is size 2, in which case there's 2 choices for how to connect it, like this. 2 choices for how to connect it, but then n-2 stuff below going on that can't connect upwards to it. It has to be sorted out with between itself and the hub. And then 3 times Zn-3, and then so on and so on and so on. And then this last term over here is going to be something like n times Z 0, or n, just plus n on the end, right? For this +4. So like plus, what's this term before? Plus n-1 Z 1 plus n. Okay. That's my plan for my formula, which I hope I explained out loud by thinking about, just like for that n=4 case, working through how big is the top group, like they told me to, thinking about how to connect it, and you make that choice of how to connect it, multiplied by ways to connect underneath. Can we do diagrams with pencil? I don't recommend doing diagrams with pencil because I'm worried that they might not get scanned in by the machine that does the scanning. If you would like to draw your diagrams with pencil, but then if you've got time, you go over them in pen, or go back and make sure it's obvious what you did. Some people, when they're using pencils, write really, really faintly, and then you can't see what they did. If that's not you, then I think you'll probably get away with using a pencil, but technically the instruction is to use a pen, just to make sure. Am I missing a 3-span one with the middle to the hub, then 2 lines down? Huh, I was missing a 3-span. Oh no, that's this one over here. Middle to the hub, and 2 down lines. That's this one, I think. Scary, because I thought I knew how big 5 choose 2 is. David would like to know in chat, is anyone applying for American universities? You can reply to David if you are. They then switched to anonymous, but slightly too late. Sorry, David. Okay. We've been asked to use this relationship so that Z5 is equal to 55. I'm hoping that's easy, but what do I know? Z4 plus 2 times Z3. Z3 I thought was 8. Plus 3 times Z2 is 3. Plus 2 times 5, 4, 3, 2. 2 times Z2. Z2 is... No. 4, 3, 2, 1. 2 times Z1. Z1 is 1 plus... No, 4. Go upwards. Cackle. Right, good. 16 and 9 is 25 plus 4 is 29. 40, 50, 55. Hooray. Okay, one more 5s. Good. Okay. We got there. I quite like a bit of question like this. It's quite stressful when you're doing the question, of course, but it's sort of nice that this working out and getting 55 here gives me some confidence that I wrote down something sensible for this equation. It's not proof that I wrote down the right thing, of course, but it gives me some confidence that I wrote down something sensible here. It's delivered me to the right answer, and also that I got the right numbers over here because I used them along the way. So somehow this kind of fits together into the framework of the question. Unfortunately, there's another part of the question. There's a rider to then go and calculate Z6, which doesn't sound hard at all. Just go and calculate it. We're just going to do loads of adding. We now know Z5, so we'll be okay. And what is this sequence? This sequence goes 1, 3, 5. Sequence is quite interesting. 1, 3, 5, 21, 55, question mark. And if you can work out what that sequence is, then something interesting is going on in there. Kimi Räikkönen, known for being very speedy. Okay, the chat message. Kimi Räikkönen, known for being very speedy. That's just caught up with the live stream. Watching at 1.5 speed, maybe starting 40 minutes in and finishing right at the end. Oh gosh, I can only imagine how great that must have been at 1.5 speed. We've got 5 minutes. I don't particularly want to work out Z6. So well, I think spoilers, it turns out to be 144. I think this sequence is every other term of the Fibonacci numbers. I think that's the case. Yeah, Fibonacci numbers go 1, 1, 2, 3. No, not every other term of the Fibonacci numbers. There's no 5. That's an 8. 1, 3, hang on. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. I think it's 144. Because I think this is every other term of the Fibonacci numbers, which is pretty weird. We had the Fibonacci numbers earlier on. This is maybe every other one. And there's a point here. Why is it 3 times 3 and not 3 squared? Well, those are both 9, so I think we're agreeing on the number. I've written down 3 times 3 because I was imagining it as 3 times, and then I had to do a big pause to think about what Z2 was. And then I looked back up here and I saw that Z2 was 3, so I wrote down another 3. And I agree, that simplifies to 3 squared. But as I was writing it, I wasn't sure that was going to be another 3. Oh, sorry, I beat Anonymous to the punchline due to the way the live stream works is that I'm slightly in the future, and that means I get a natural advantage on doing the punchline for everything. Okay. There's a request to prove it in chat, which the way you would prove it, if you wanted to prove this, is probably by induction, which not everybody has seen, but if you like, is it? Oh, how would I prove it? I would try to get from this statement to the statement about Zn plus 1 to create some sort of relationship between the Zs. This one's quite complicated, but maybe I could spot, hiding within that definition of Z, maybe I could spot some sort of secret extra copy of Z or something to make this not quite the relationship with the Fibonacci numbers, but something a bit like the relationship with the Fibonacci numbers. Do they do the thing I want them to? Do they form some sort of recursion relation? I suppose they must do. I think that's how I'd approach this. Let's try and work out what the relationship between Zs is in a more simple way, like using this expression on itself. to try and simplify this down. I'm trying to do it in my head while talking, can you tell? Or maybe even just expand everything and try and recognise terms. Tempting. Why is it 2 times 3 for part 3? 2 times 3 rather than 3 squared. Okay, so the 2 comes from having 2 ways to connect the top group. The top group either connects like this, connecting the hub to the top point, or it connects by joining this to here. This is not the problem with 3 solutions, because I have to have this line in here. I have to have this line in, because that group's got to be size 2. So it's not the same as the previous part for how you connect this top bit. That's why there's only 2 ways to get this top thing, because I have to have that line in. But there are 3 ways to connect the bottom bit, because I don't have to make another group of size 2. I could have 2 ones. Okay, so these things are different for that reason. That's why it's 2 times 3, not 3 times 3. Thanks for getting me to go in there. The first sub-question is worth more or less than the last sub-questions. There's no logic to it like that. It could be the other way around. It could be that a middle part is worth lots of marks. They don't have to get more important. They don't have to get less important over time. This one, I reckon this one is probably worth lots of marks, and this one is not so much. And this one is not so much. So I think this one is like this, in terms of how many marks for each part. Okay, I regret writing with the pink pen. Somebody asked me not to before. For accessibility, I'm going to delete it all. That doesn't feel very accessible. FG's here, they're a little bit late. Cool. Why don't we scan the map papers and not do the actual hard copy? We used to do the hard copy. We switched over because of COVID when we were marking online, and continuing to mark online. We did it a second time because the world was like that. We're doing it again because we want to keep using the online platform. Quite like it. Marking online. Scanning them all in is something we've decided we want to do anyway, because we're using a little bit of for the multiple choice. We're now testing out some ideas about scanning it, but we're still getting humans to look at it. This is too much behind the scenes. This is exactly my job. Behind the scenes, we're doing some moderate scanning, but also still getting human to look at everything. So we're quite keen on the idea of scanning in computer things. We found it worked okay, and it also made distributing the papers to markers much easier. Physical scripts are surprisingly heavy, especially when you've got 5,000 of them, and not moving the scripts around the building is seen as a plus. Somebody learnt 1 or 2 things, which is, I mean, that's why we're here. That's what we're doing. There is an extension on this one that we're not going to talk about today, but it's exploring that sequence from the warm-up. We worked out a few of the terms. They're famous. They're called the Catalan numbers. I think people in chat knew that, or some people in chat. A couple of people in chat knew that they were called the Catalan numbers. This problem is great. These numbers come up everywhere. In particular, it's the number of ways. This thing where you're splitting up a polygon is the number of ways to do that. Splitting it into triangles. Oh my goodness. Do we know how many marks each person? Lando Norris wants to know. Do you know? You know for past questions, because the model solution, web solution mark scheme thing on the map page, let's have a quick look at it together, has got that printed on. The questions don't, but the work solutions we publish do. I'm trying to show you, but I'm currently logged into the website, which makes everything look weird. So I'm just logging out of the website. Give me 2 seconds. I'm live still? I'm live still. It's 7 o'clock, but I'm still live. We started a bit late. It's been an up and down live stream, full of twists and turns and recursions and that. I might trim the start off. It might be that bad. The replay don't need to see this. So for past questions, we don't publish the actual questions, the number of marks on the question, but in the answer, we have this kind of breakdown where we'll say, for this part, this was worth 2 marks, this was worth 2 marks, 2 marks, 2 marks, 2 marks. Good. Sneak preview of the solutions to some questions from 2020. 4 A-levels, question at the top there. No, standard conditional offers are based on 3 A-levels, including for maths and computer science. 3 A-levels is enough for us. How do you correct mistakes? You can scribble them out and put a tick in a different box. Still looking at it with humans, don't worry. We'll work it out. Good, okay. Can you take rest breaks in the map if you... I'm going to do questions. People are putting loads of questions in chat. I'm going to talk to chat for a little bit. Some people are off. Bye if you're going. Thanks for bearing with us through technical difficulties. I think this is the first time that we've had technical difficulties and then still done 2 hours of live stream rather than giving up. So I had more fun than if we gave up. Right, questions. Rest breaks. If you normally have rest breaks, you don't have to officially apply for this at A-level. Talk to your test centre. Talk to your exam centre or test centre, the place where you're doing the MAT. Talk to them about rest breaks. Okay. Questions are marked. If people want to go behind the scenes, look, this is behind the scenes. This is me. There we go. I'm going to highlight that. The papers take a surprisingly long time to mark, but I can't give you an exact number because the questions are marked separately. We have marking teams for each question. Lots of tests work like this. That we have specialists. We have a team. We have a team on each question, and they mark that question, and that helps them focus. And it means that if you say something silly on one question, then almost certainly it's a different marker marking the other questions who won't have seen that. So you don't get any follow through influence from other questions, if that makes sense. There's a thing that markers have to be aware of if they're marking lots of questions in a row. Not for our test because we split it up, but if you were one marker marking lots of questions in a row, you have to be aware that if you gave someone the benefit of the doubt, you're then aware of it later on, and you might try and do something different that you wouldn't have done necessarily. There's this sort of halo effect thing going on. We get around that by having separate teams. What if I show you the paper? I did not show you the paper. Actually, I was very careful. I'm scamming you for this full 2 hours. Scams. How are the marks allocated? The mark scheme does show which parts are worth marks. I just showed you. Stream lag. Imagine it was like last year where it was only 1 hour. Here's the capital letters. Yeah, didn't get anything done. That was a good summary of last year's live stream. Imagine this, but at double speed. If you're watching the replay, you don't need to imagine it at double speed. You can click that at any time, but I wouldn't. I wouldn't. Is it worth taking computer science as a 4th A level? Gosh, I don't think it hurts, unless it affects your grades in your other 3 A levels. In which case, gosh, I'm getting nervous. But computer science at A level is quite different from computer science at university, so it's not going to be as helpful as you maybe hope. If you've got the chance to do 4 A levels, then do 4 A levels. Sounds sort of fun that you're learning extra things. Not everybody gets that chance. It's sort of your last chance in the UK system to be doing 4 A levels, 4 things all at once. And maybe make advantage of that, but not if it's going to affect your grade in maths. Top 5 mathematicians. We already did a shout out for Sophie Germain in this live stream. Emmy Noether's absolutely brilliant. I might have been thinking of Emmy Noether's page earlier when I said Sophie Germain's page was great. They've both got good Wikipedia pages. Maya Mizukani, Vicky Neal, and Gauss. Good. Is it better to do math or further math for comp sci at Oxford? It is, I think, recommended that you do both if you're doing A levels, because we love both of them for computer science at Oxford. Check the CS website, cs.ox.ac.uk, for more information about their admissions policy for computer science. I didn't put Wiles on the list. Hardy is a good mathematician, very mathematician's mathematician. I didn't list loads of mathematicians. Vicky's been on this before. Well, Vicky's been on Maths Club. Irish wasn't there. Mames Junro. Should I have picked Mames Junro from chat? There's one person whose calculator I signed. I didn't realise they were one of my top 5 mathematicians as well. Good, cool. Erdos should have been on my list. If I put Erdos on the list, does that count a little bit for connection numbers? No, maybe not. I can actually think about this now. Right, good, okay. Ada Lovelace. How did I forget? I've got posters downstairs. Ada Lovelace worked a little bit. Some people say invented computer algorithms. Would have been appropriate for the computer science special. Good times. Anonymous person, I signed 3 calculators that day because I did sign the calculator they brought me, and 2 other people heard about it and brought their calculators along as well. So that was a whole thing. I have forgotten Terence Tao and Alan Turing and a bunch of mathematicians who taught me and were actually influential on my life as a mathematician by telling me about maths. What's the best advice I give? Oh, this is good. I've got a couple of minutes. Best advice I'll give to a math applicant. I've actually come a long way with it. So a while ago I would have said something very boring like do lots of math questions. Recently I've managed to evolve that into do lots of maths because I've realised that they don't actually have to be math questions for you to practice the skills. I think I'm getting closer to my main advice being it's just maths. That I get lots of questions about the weird stuff that might be going on in the mat or other stuff, or is this very scary? I mean, it's just maths. It's weird and the problem solving's turned up to 11, but it's just maths. That's not very good advice. I think I might go back a stage, just cool down one step to try other maths problems. They don't have to be maths. So long as you can't do the maths straight away, as long as you can't do the maths straight away, it's good for you to be stuck on the maths problems, whether or not they're math problems, whether or not they're mine. Oh yeah, don't cheat. Oh yeah, the 2 rules. Don't swear and don't divide by 0. Good. Extenuating circumstances. Yeah. We want to take something into consideration. Gosh, blimey, Lando. Sorry to hear about that. I don't know where you can declare that, but at the very least you could let your college know if you wanted them to, especially if you think it might affect math performance. Good. Okay. Someone asked if I went to Oxford. Who's going to tell them? I went to Cambridge. I studied at Trinity College, Cambridge, for 8 years. I did 3 degrees. Didn't actually miss one. I met my students yesterday. That was nice. I've got six students who I'm just teaching a little bit of maths this term, but I met them yesterday. They're nice. I'm going to try and get some of them on the live stream. We'll find out. 8 years. Yeah. What did I do? Undergrad for 3 years, master's year for the 4th year, and then 4 years of PhD. It's 4 years for 2 letters. 3 if you spell it out as PhD, but it's not my style. 4 years, 2 letters. Goodness me. Plus a thesis to write a lot of maths. Those are my degrees. The BA M Math PhD. That's quite a normal progression for doing degrees, that you do an undergrad degree, you do a master's degree, and then you do a PhD, or some people say DPhil for that one, Doctor of Philosophy, where you do some maths research. The next step will be doing postdocs, where you don't get any new letters to put on your name, but you do more research positions, going into academia that way, but I stopped after PhD. Yeah, that's a normal sequence. Lots of UK universities offer this kind of 4-year programme which is combined undergrad and masters, which is what I did. What Oxford do as well. Also call it the M-Math, Master of Mathematics, where you apply but then you do 4 years. We abbreviated it to TMO for even shorter when I was there. Even shorter. My thesis is on my website. You can download it if you like. It's about coalescing bubbles. There are some GIFs on my departmental website. You don't get all 5 letters because you can't write. Guys, you don't get all 5 letters because you can't write doctor and PhD. That's not cool to write both, unless you have 2 doctors. In which case, doctor. I think I have too many PhDs. Me too. I've got that joke prepared for when I get my second degree. No, don't do a second PhD. I haven't done 4 years. Right. Thoughts on Oxbridge giving out BAs in STEM subjects? It's traditional. It doesn't ultimately matter because it's still a STEM degree. It's obviously not what you would pick if you were starting now. You would say BSc, Bachelors of Science, because come on. But for traditional reasons, Oxford says BA, Bachelor of Arts. I
I think, yes, if you do the combined 4 years undergrad and masters, I think you still get BA as well as MMath. I think you get a BA/MMath. I think. Don't quote me on that. That might not be true. That's very much the sort of thing that might not be technically correct. You could definitely put both of them on your CV. Right, good. Art maths. I want to do more mathsy art stuff. I think it'd be good. We've got an art exhibition going on at the moment. I would love to show it to you, but I can't do that now because I need to go and get a train. Good. Advice for aspiring professors. Same as the MAT advice. Find questions you can't do straight away. Find problems that you can't solve immediately, and then solve them, and then tell everyone else. That is, I think, professor advice. I'm not a professor. Some of my friends are on that career path. They're doing very well. They're all stuck on maths problems. They are all stuck and gradually getting unstuck on their maths problems. Right, cool. Yeah, MSci, I don't know, MMath, Master of Mathematics. I have mastered mathematics. It's what I came for. Right, good. Right, we're stopping. It's over. It went up. It went down. It went sideways. We're back 5 p.m. next week to actually go through a past paper. We're going to see how that goes. So in the meantime, if you want to try the past paper, you can grab a copy on the Matt Live website. I'm there. I will see you in a week. Have a great week. See you in 166 hours. Bye.